First of all, for us to work with law of conservation of mass, we actually have to keep track of the mass by looking at how many atoms of each substance are present before and after the chemical equation. Okay, so if you recall, in every chemical equation, we have a reactant side. This is the things that we put in. This is the stuff that goes in before. Then we have our equal sign or our arrow, and these are the things that occur after. Okay, so we have our befores over here, our afters over here. We call the before the reactant side and the after the product side. So when we count atoms in a substance, key things we have to look at. First of all, there are things called coefficients. All right. And a coefficient is the normal size whole number in front of a substance, okay? So this is new. We haven't dealt with coefficients before. So if we look over here on water, H2O, there's a number sitting out front of that. That's called the coefficient, okay? This number here tells me how many H2Os I have, okay? You'd almost want to like put parentheses around the H2O and say, hey, this 2 multiplies to everything behind it. Now we don't use parentheses, but in math you probably would. If you don't see a coefficient, you assume it's 1. So right here on this magnesium hydroxide, there's no coefficient here, but it just says, well, we have one of these groups together, okay? The subscript we've been using a bunch in here already, so that's not new to us, okay? The subscript, that's the smaller number behind an element, okay? So that when you write the number smaller behind it, it's for that substance, okay? It tells us how many atoms of that element are in that substance. So for example, I see I have a 2 following this hydrogen. This means I have 2 hydrogens in this compound. Now you'll notice that there's no 1 behind the oxygen, okay? And when we did our naming unit, that sometimes trips some people up. So when there's nothing behind it, that just tells you that you have one of them, all right? So we go down, let's say, to this bottom one. We have 2 carbons and we have 8 hydrogens. Now we go up to this one that's a little bit more confusing, and we have 2 aluminums. And then we have a 3, and that 3 combines to everything inside. So we have 3 SO4 groups, okay? So when you're counting these, you're actually going to say, hey, I have 3 groups of SO4. Or you could say I have 3 S's and 12 O's, because it's 4 times 3. So I have 3 S's and 12 O's, all right? Okay, so these are some examples that we're taking a look at as we kind of break this down. Now, the best thing to do the counting is actually to do some practice, or do a bunch of practice to be able to do this, all right? So we have 6 of them here on the screen, and we're going to work through all 6 of these and practice counting these atoms in the substance, all right? So to do that, I'm actually going to work off the iPad here and kind of rewrite it. I have 2H2O, okay? So at 2H2O, if I want to know how many hydrogens I have and how many oxygens I have, well, this 2 multiplies to the hydrogen and to the oxygen, so it counts for both. So for the hydrogen, I have 2 and 2, so I have 2 times 2 for a total of 4. For the oxygen, there's nothing written here, but that would be the same as having a 1. So I have 2 times that 1 for a total of 2, okay? So for the water, I could say I have 4 hydrogens and I have 2 oxygens here right now. Okay. Now, let's move on to the next one. And we have our magnesium hydroxide. And with magnesium hydroxide, the magnesium, and I have the hydroxide. This is the hydroxide, this OH grouping. And there's a 2 outside of those parentheses, all right? So I have my magnesium I'm going to count, my oxygen I'm going to count, and my hydrogen I'm going to count. Well, there's nothing written here, so that tells me that's a 1. So magnesium, and there's nothing out here, so that tells me that's a 1 also. So I have 1 times 1, which is 1. Again, I have 1 to this oxygen, but there's a 2 here. And this 2, so because of the parentheses, I'm getting lots of lines in here now. Let me get rid of a little bit of this stuff. Some of the extra junk. Because of this parentheses, this 2 represents the hydrogen and the oxygen because we put these parentheses in here, okay? So I have 1 overall grouping times this 2 for the oxygen, for 2 oxygens. I still have 1 overall grouping and this 2 for the hydrogens. So I end up having, right, a total of 1 magnesium 2 oxygens, and 2 hydrogens. Let's go on to the next one. So here I have 3 with the aluminum, which is a 2, and I have SO4 in parentheses, and then a 3 behind that. Now, if you can do this one, you can do any of them, because this is about as complex as it possibly can get. Okay, so we have aluminum, we have sulfur, and we have oxygen. And again, we have 3 groupings of this, so that 3 is going to multiply to the aluminum, it's going to multiply to the sulfur, it's going to multiply to the oxygen. Okay, so if we're just counting these, this formula represents how many atoms we have. Okay, well, the aluminum we have 2, so we're going to have 3 because of the multiplier, the coefficient, times 2 because of my subscript. 3 times 2 is a total of 6. Okay, now let's go to the sulfur and the oxygen. We might want to make a note that the sulfur, again, has nothing here, so that's the same thing as having a 1. Absolutely, draw the 1s in if it helps you, okay? So we have, again, the sulfur. I still have groups of 3, so I have 3 times, that's going to multiply to the sulfur, which there's 1 in the grouping, and then I have 3 sets of X. If you remember, that 3 works backwards into both of them, okay? So I have 3 times 1 times 3 for a total of 9, okay? So I have 9 sulfurs here. Now the oxygen is going to be our big one, all right? So again, let me get rid of some of the junk that might be throwing us off. And again, I have my 3 times the 4 times the other 3 that multiplies the oxygen. So it's going to be 3 times 4 times 3. Okay? So 3 times 4 is 12. 12 times 3 is 36. So I end up having 36 oxygens there. So I have my 6, and I have my barium, and I have my chlorine. All right? I'm going to spend a little less time working it all out and go a little faster now. All right? So I have my barium and my chlorines, and I'm going to take my 6 times the barium and 6 times the chlorine. And again, if I don't remember, well, there's nothing written here, that means 1, okay? So I'm going to take 6 times 1 equals 6 bariums. I'm going to take 6 times 2 equals 12 chlorines, okay? Next one, we have our gallium nitrate, all right? And gallium doesn't have anything in front of it. The nitrate ends up being in a parentheses with a 3 on the outside of it. So again, I'm just going to make a little note to myself, hey, that's a 1 out here. Whenever I don't see it, that will help remind me of that. And I know that 1 multiplies to every single thing in here. So my gallium, my nitrogen, and my oxygen. Okay, and I'm also going to make a little note that I don't see anything here or here, so that's the same as having 1s, all right? And remember that this 3 multiplies backwards to both of those. So gallium is going to be a 1 here times 1 times, nothing else actually, it's just 1 times 1. So there's going to be 1 gallium in this one. Whoops, didn't mean to do all those. The nitrogen, I'm going to have 1 right here out front to the nitrogen, which is another 1, but it also has a 3 out there because that 3 goes back to everything that's inside of these parentheses here. It does not affect the gallium. It's only the thing that's in those parentheses. So I'm going to have a 1 times 3, or a total of 3 nitrogens. Okay? Now taking a look at those oxygens again, because they're the bugger. They're the one that's going to be hardest for us to keep track of. All right, we're going to clean this up again. And let's take a look at those oxygens. First, we want to make sure we put our parentheses back in, because that was belong there. All right, and there's nothing out here, so that's a 1. It's a bad 1. And I'm going to multiply the 1 times the 3 times this 3 also. So it's 1 times 3 for a total of 9 oxygens on this one. Okay? And again, all we're doing is keeping track of how to count these atoms because in a very short time, we're going to have to decide what this is. Right now, I'm telling you what it is, but in the future, we're going to have to make the decision on what we want to put here to make everything balanced, okay? That's kind of why we're counting now, so we get used to putting these numbers in. All right, last one. We have our zinc phosphide, and there's 3 zincs, and there's 2 phosphorus. So zinc and phosphorus, and there's nothing, oh, there is something out here. There's a 4 out front here now. So that 4 is going to multiply to the zinc. That 4 is going to multiply the phosphorus. So I'm going to go 4 times 3. That 4 times the 3 for the zinc for 12 zincs. I'm going to take 4 times 2 for 8 phosphorus on this. Okay? So that's how we do it. Now, this is a single compound. It's one compound that we've been talking about. So we had one compound here, and one 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 here. But when we look at a complete balanced equation, we're going to have 2 or 3 or 4 or 5 of these in any given equation. So we're going to have to do this 3 or 4 times for every single problem that we're going to do. Okay? Take a look at this slide now. You'll notice that when we actually get the entire chemical equation, it's not just one compound, but it's a second one, and a third one, and a fourth one. We need to start counting the number of atoms that we have. Okay? So when we do this, we do all the same rules, we do all the same work as we did before, but instead we just keep track of our reactant side and our product side. So notice how I don't even care if sodium is in this compound with the sulfur or if it's not. I just list every element out I have, okay? So step number 1 in this process is you take your sodium, your sulfur, your barium, your chlorine, everything on the left-hand side of the arrow, we're going to list them out, okay? You should see that they had the exact same thing over here, sodium, sulfur, barium, chlorine, on the right-hand side of the arrow, all right? So we have the left-hand side, we have the right-hand side. And then we just start counting them like we did before, all right? So again, we're looking at this sodium sulfide, and our barium chloride, and they're making the sodium chloride and the barium sulfate. So again, I sometimes just divide it in 2. I have my reactant side, I have my product side, and I have my sodium, my sulfur, my barium, and my chlorine. And I have that on both sides. Okay? And I'm just going to start counting. All right, so the sodium, there's nothing written out front, so that's a 1. Okay. I'm going to change colors here so we can see that a little easier. So there's nothing out front, so that's a 1. The barium, there's nothing out front, so that's a 1. Here we have a 2, so that stays. And over here, this barium doesn't have anything out front, so that's a 1. So if you don't have anything out front, it's a good idea maybe just to write those 1s in to remind you. And now we're going to count. So I have my sodium, so it's 1 times the 2, so I have 2 sodiums. And I have 1 times the 1 sulfur, so I have 1 sulfur. Now I have a plus sign, so a plus sign is a divider, because this one only pertains to the things that follow it until the plus sign. The plus sign breaks that apart. Okay? So now I have a 1 times the barium, so I have 1 barium, and I have a 1 times the 2, so I have 2 chlorines. On the product side, I do repeat that work. Now, if you do it right, if the equation is balanced, in theory, they should be the same. Okay, let's see if they are. So I have a 2 times 1, and that's a 1 also, that's a 1 also, that's a 1 also. So I have a 2 times 1, a 2 times 1. So I have 2 sodiums, 2 times 1, I have 2 chlorines. I have 1 times 1 and 1 times 1. I have 1 sulfur and 1 barium. Okay? So as we take a look at this, that's how we want to count these out. All right? Very shortly, we will get to a point where if we take a look, let me erase some stuff here again. Get rid of all the junk. Start where we've had it before. Okay. Very shortly, what's going to happen is we're not going to be given this number here. Okay, so I want to kind of give you an idea what's going to happen. That won't be given. And instead, what we'll do is we're going to put a bunch of a blank in and say, okay, what goes here? What goes here? What goes here? What goes here? So you have to decide what belongs in these coefficients to make these equal each other. So for today only, they're all going to equal because I've done that purposefully because we're learning how to count. But come tomorrow or the next day, that's when we have to start doing the next step, which is figuring out what belongs inside of here. Let's do another one. So again, I'm going to write it up because it's kind of easier to work off the iPad. Again, I'm going to divide it up. I'm going to have my reactant side, my product side. And I'm going to write down, well, I have aluminum, I have oxygen, and I have carbon. Okay? So the aluminum, again, we're going to make that a 1 out front. We'll put a 1 here to help us out. Well, I have 1 times 2, so I have 2 of those. Oxygen, I have 1 times 3, so I have 3 of those. Then I'm going to come over here, and my carbon, I have 3 times 1, that's a 1. I have 3 of those. And I have 3 times 2, and it's plus, so that plus sign comes part of that. So I have 3 times 2, which is 6. So I have a total of 9 oxygens. So you see how I kind of do that? I do the 3 from this compound first, plus the 6 from this compound to give me my total of 9. Now on this side, I have my aluminum, my carbon, and my oxygen. I have my 2 aluminums, and then carbon, I have 1. There's another 1 there and a 3. So 1 times 3 is 3 carbons. And I'm going to switch this because I don't like how I did that. I'm going to move you down. I'm going to move you up. I kind of like to leave them in line. That helps me out. So I have my 3 carbons and my 3 carbons. My oxygen, I have 1 times 3 times 3 for a total of 9 again. All right? Kind of see how they work themselves out, okay, in this. Now, the last one we're going to do for practice is taking a look at this next one. And this one I'm not going to work off the iPad. So this one we're just going to talk it through and see if you can follow along, okay? So here I have my lead, and there's nothing written there, so that means I have 1 lead, all right? Here I have my nitrogen, and there is times 4, so I have 4 nitrogens here that I'm going to be working with, okay? So 1 times 4. Here I have my oxygen times 3 times 4, so I should have 12 oxygens, okay? And then I have my calcium. Now there's a 1 here, but I have 2 groups of that, so it's going to be 2 times 1, so I'm going to end up with just 2 calciums here, okay? Now on this side, if we count everything right, we should get the same totals. Let's see if we do. So lead's all by itself here, so I get 1 lead, okay? The calcium I'm going to do next. No, I can't. I'm going to do the nitrogen next. The nitrogen, I have a 2 here times 1 times 2. So 2 times 1 times 2 is a total of 4. Okay. The oxygen, I have a 2 times 3 times 2. So 2 times 3 is 6. 6 times 2 is 12. And here I have finally my calcium. This is a 1, so I have a 2 times 1 for my 2 calciums. Okay. So that's how we count the number of atoms inside of a molecule. All right, that is the video lesson. The following quiz is going to basically have you do several of these counting things to check to see if you know how to do this. And then tomorrow we'll do additional practice and make sure everybody is caught up and ready to go for tomorrow. Thank you.